Hey everybody, so yeah, this is a video for Tessim installation. I've been making a few videos. I don't think anyone actually watched it, but yeah, so it's something that I've been working on, and just thought it might be useful for a few people out there. So I just made a video on what I'm working on how to use it. So I'm calling it Tessim. It's a kind of a simulation software, and it works with Python, and its aim is to enable embedded simulations for embedded systems. It can simulate your embedded software, like whatever going into your microcontroller, and a few hardware components like a few basic circuits and some motors and stuff like that. So the aim is to provide a software where entire embedded systems, hardware, software can be simulated, because most likely they'll be going to the field together. They can be simulated and tested in the same environment, and in order to smooth out the development of embedded systems. That is the final aim. So in order to get started, let me show where you can download it from here. I'll paste this URL in the video description below, and just simply download the zip file, or you can clone it also, doesn't matter either way. Open the zip file. It's a small half an MB file, won't take much space right now. Okay, now just I'll extract it anywhere you want. I'll extract it in let me call it Tessim demo. Demo installation. Great. Okay, now just extract here, show me the files, and okay, this is all there is actually. And so now once you have it, new window, let me go to that place where it's installed, Tessim demo installation, and then to Tessim user main. Here, when you come here, you might want to check the path and just add this path variable to this particular name. So add Tessim path equals this path. It might be different for you, but this is what it's coming for me, depending on where you install your system details. Just copy wherever you've installed it, the path, and make it into an environment variable, and export this particular variable, and main installation is done here that way. So now in order to get started, I'll start off with a very simple system. And what the system is, we got a phone call somewhere. Okay, so this is what we'll be simulating this time. Just start with, this is a simple motor. Oh my bad, this is motor, and this is how you declare it, and it will be connected to two nodes. So Tessim works with nodes. You can connect your component to nodes to assign those nodes to values. They can act as inputs. Nodes can take any kind of values: voltage, motor speeds, torques, whatever you want. And that's how it do here. Okay, in order to start, let's just start off in a new file and save it as, where do I save it? In Tessim installation. I'm saving it here actually. Once you have exported it, you can save it anywhere you want, and save, and it's saved. Okay, so thing is, you might want these few lines here because it's a local library. So in order to tell Python where to find that library, you'll have to add that path to your Python script, and the first 4 lines are just that. Beyond that, it's normal Python. Okay, so now, as I said, for the motor model, we will need 2 nodes, and I'll just make nodes equals to CLI dot create nodes 2. Now we have 2 nodes numbered automatically with 0 and 1, and I'll have empty is equals to CLI dot DC motor these parameters, I'll take them directly from here. I found these parameters in some random YouTube lecture about system modeling, and I'm taking those, and that's it. We have our motor. Now we want to connect the motor, so we'll do empty dot what was this, set nodes 0 1. You want to put the value on the node, so CLI dot put value. So put value function will put a node number. I want to put 10 volts on node number 0, and then just actually, in order to get speed, you might want 3 nodes. So this is kind of a default. So if the terminal, it's a motor terminal, by default it will treat it like a voltage. And so here what I will do is empty dot set speed node and make it the node number 2012 as my speed node. So this node, you don't just assign it and it automatically notes that whatever value is coming onto this node, it's a motor speed. It takes care of that unit by itself. You don't need to tell it which node is what. So that's one thing. And simply exec, so exec call function, you can execute. Let me just take some for 2 seconds, and this is my timestamp. Sorry, the time division used for the simulation, and this is the time period. Now we want to plot whatever I have, so you can simply import the Python plotting library, which is from matplotlib import pyplot as plt. I don't know why I do that. Plt dot plot. Now the thing is CLI dot simulation time and CLI dot get what was the recorded nodes and node number 2 because that has our speed, and plt dot show. So this is our script. Let's now try to run it and see what it gives us. Up in naming my file, so I don't like this name, so let me, oh, it's not showing me this file. You can't rename it here directly. Oh, with that, I'll just rename it here. I don't like this name, it has a space in it. I'll rename it as demo1. So I renamed that file, and now I can just run demo1.py using Python. Just run that script, and it gave me this, which is my speed of the motor as a function of time. It's settling down at some value. Okay, that's it for this video, and I'll be making a few more videos. I'm planning a series on control systems and kind of embedded control systems. It will be a mix of control systems and embedded systems because most likely anywhere in practice they will be implemented together. So I'm planning a video series on that where I'll be using Tessim for actually, there'll be a more, I'll be trying to control a motor using the C code in Atmega and kind of see that exact C code which can be uploaded to the Atmega directly and just see how it responds. And in the process there'll be a lot of content about embedded systems also, like how to registers work, how to PWMs work and stuff like that, and control systems as well, how everything in the control system theory and all that works. So keep an eye on that, and I hope you found this software useful, and I hope you found my coming up lecture series useful. Thank you.